This AvOrigin Gadget tutorial is all about origin and transform nodes, which allow you to position pieces of the visible or interactive elements in your gadgets relative to the hands or head or any other part of the scene that you like, as well as resize them, rotate them, scale them, move them around, etc. So the first thing I'm going to do is demonstrate a little bit about how the iteration work loop looks like when you work on gadgets. First thing I will do here in my gadget project is open a new terminal. And in this new terminal, I'll run npm start. npm start causes the TypeScript compiler to sit there and watch for file changes and then automatically rebuild everything when a file changes. So as we go through this, it will just automatically rebuild in the background. And then I'll split my terminal, and on the other side, I'll run npm run dev server, just like I did in the example gadget tutorial. Here in my gadget, I have an empty gadget, just like I ended the initial gadget tutorial with. And I will paste in some code here that includes a transform node and a model. We're not going to go deeply into what the model does in the model node. In this case, all that you really need to know is that it shows a model. We'll get into that in a future tutorial, exactly what that's capable of doing. On the transform, we can specify X, Y, and Z translation, X, Y, and Z scale, and X, Y, and Z rotation. That translation is measured in meters, so this is a translation of positive 0.5 meters. Scale is measured as a percentage or a ratio of how big you want the thing to be, so 1.0 is no scale at all. And rotation is measured in degrees around whatever specified axis. Now that we have this change, we save the change. We see that our npm start window here has already updated it. Now we'll switch over to VR and see what it looks like. Here in my favorite gadgets, I see that I have my gadget instance just from before. And I can create that. And now in addition to the cube, I see a little rocket ship 0.5 meter above the grapple. We're going to switch back to code and continue to change this. But before we do that, let's move our hand over this, press and hold the A button, and then select this recycle icon, which causes that gadget to disappear because we've closed it. We've played a little bit with translations. Now let's try scales. We'll make some minor changes to this transform here by setting scale in Y to be 0.5 and scale in Z to be 2.0. And then we save and go back into VR. So now when I look at my rocket, I see what I expect, which is I am scaled 2x in Z. I am scaled 0.5 in Y, which is up and down. And I end up with a short, fat rocket that doesn't really look like a rocket anymore. Most of the time when you scale something, you actually want to do a uniform scale where it's the same in all directions. The transform node supports that. You don't have to specify all these arguments. You can specify just one. It does that with something called uniform scale. So let's make our rocket twice as big in all dimensions. Now when we make a new instance of our gadget, we will see a big rocket. So we've played with translation, we've played with scale. Now let's try playing with rotation. Something that is true for not just transform nodes, but all node types in Aardvark and really all node types in React in general, is that you often don't have to specify all the parameters. These properties will all have defaults, and a relatively small number of them are required in the case of most nodes. In this case, everything is optional, and if you don't specify translation, you get no translation. You don't specify a scale, you get 1.0 or no scale. Don't specify rotation, you get no rotation. We're done playing with scale. We'll just delete that. We'll replace it with just rotation. And then we'll switch back to VR to see what we get. Now that we're here in the VR view, if I make a new instance, you can see that I get a rocket that is horizontal, which actually makes it look more like a blimp. But we've rotated around Y, and we've rotated around Z, and we end up with a rocket on its side. That's essentially everything that you can do with transform nodes. They allow you to do all sorts of things with positioning, scaling, and rotating things within the parent transform. But what if we want a different parent transform? Well, next let's try getting rid of all of this code and replacing it with an origin node. Origin nodes set the root transform of that section of the tree to one of four things. We'll get into what those four are. As an example, we'll start with user hand left. This is the user's left hand. Within that, we'll have a transform that rotates this model we're about to show just to make it be facing the user. And let's go look at what this looks like in VR. So I still have my grabbable that I can move around, the little cube. In addition to that, I have a left hand icon on my left hand. This doesn't do anything, it's just a model. but it is position belted for the hand. It is automatically has its position updated without any code running at any kind of rapid frame rate in the gadget itself. At the moment, there are 4 possible origin paths. The origin, it can be /user/hand/left or /user/hand/right, which attaches that section and its children to the left hand or the right hand. It can be /user/head, which attaches that section of the scene graph to the user's head. Or it can be /space/stage, which attaches it to the user's room origin, the center of their tracking space. But now let's go ahead and look at what these look like in VR. So now you can see I have a head icon attached to my head. As I move my head around, it moves with me and is head-locked at all times. I have a right hand icon attached to my right hand. I have a left hand icon attached to my left hand. And if I turn around and look at the origin of my tracking space, I have an aardvark. I have an aardvark icon sitting in the center of my tracking space. So that's how we use transform nodes and origin nodes. You can put anything you want under these nodes. You can put panels or models or any of the other nodes that we'll end up talking about the other tutorials. And what this lets you do is control exactly where things are positioned in a declarative way that doesn't require you to run code in your gadget every frame. I hope this tutorial was helpful. If you have any questions about things that weren't covered very deeply here, or things that you think should have been covered here, other tutorials you'd like to see, or any other feedback about Aardvark, please leave a comment below. Thank you.